Hello everyone, welcome to the fourth update of the Discover350 series. Since the last episode, we have made a good amount of progress on the avionics, systems, 3D models, and textures for the A350. First, you'll hear from one of our avionics developers, and there's a lot to cover, so let's just get straight in.
Welcome on board the flight deck. I'm Plasma, and I have primarily been working on the multifunction display, or MFD for short. I joined the team shortly after the release of episode 3, amazed at everything that DFD accomplished so far, and decided I wanted to help create this high-fidelity A350. I'm a highly experienced self-taught developer, and I'm really excited to show you everything we've accomplished on the MFD so far. But those of you who are expecting flight planning functionality, you're in luck because that's the first thing I'll be demonstrating. As promised, we are using fly-by-wire simulations FMS V2. Since our aircraft will be open-sourced under the same license as fly-by-wire aircraft, there's really no reason to recreate something that has already been done, and it saves us a lot of time. During this demonstration, I'll be creating a flight plan from scratch to show you the features we have implemented. But also keep in mind, this is a work in progress and not everything shown will represent the final product. I can already hear some of you asking if there will be sim brief integration, and the answer is yes, just won't be shown here in this video. With that aside, let's dive right in. First thing I'll do is I'll click on the active button and navigate to the initialize page. From here, I'll put in a flight number, a departure airport. I am at Oslo, so I'll put in Oslo's departure code, and then I'll put Copenhagen for the arrival. I'll put in any cruising flight level and a random cost index. Now I can press on the active button and navigate to flight plan to work on the flight plan. From here, I can click on the departure code to set a departure, and then press departure from the menu that opens. And now I have the option to choose a runway, SID, and transition. So from Oslo, we will be departing off 01 left with the Oscar 4 Alpha departure. And there is no transition available, so the plane does not give us the option to choose a transition. From here, you'll have noticed a new button has appeared at the bottom right of the page. When I click on it, it will take me to the main flight plan page, where I can then scroll through all the waypoints that has been entered for the SID. And I can insert it by pressing on this insert button here. Now, we'll configure the rest of our waypoints. From OSCAT, we can manually enter airways by clicking on the waypoint, then pressing on airways from the menu that appears. Here, we have the option to enter our airways and the waypoints here. From OSCAT, we need to take this airway to the Kelin waypoint. From Kelin, we have to go direct to Topla. And from Topla, we have to take this airway to the Ernov waypoint. And once we enter all our waypoints in, we can press on this button over here, and we can scroll through our flight plan to make sure everything has been entered correctly. And as it has been entered correctly, we can press the insert button here. Now, the button you can notice over here is this, which has our destination airport on it. This is especially useful if you are doing a really long flight and you don't want to have to scroll through all your waypoints to access departure information, which you can access by just pressing the button, and it will automatically take you to the page to plan your arrival. SimBrief has given me, SimBrief wants me to land on 04 left. We'll do the ILS approach for 04 left. And the star will be the Ernov to Alpha Star. And if we have to, we can choose any wires, approach wires if needed. I will keep this as none for now. From here, we can press this button to take us back to the flight plan page. And we can scroll through everything to make sure everything has been inputted correctly. So you can see from Ernov, we have our SID waypoints here. And then there is a manual leg with a discontinuity, which means there will be radar vectors to the approach fixes for the ILS 04 left. From here, you can just press insert to insert the waypoint. You can also notice we have some discontinuities here. So we can delete these discontinuities by clicking on a waypoint and then delete. And then we can press insert to save the flight plan. You shouldn't be doing this if you're flying on VATSIM or just in general. Instead, once you reach the waypoint, you should just go through the flight plan page and take it direct to the next waypoint. But you can still clear discontinuities. Great, we have successfully filed a flight plan for the FMS. Now, we can move to the other parts of the display. For example, checklists. We can access the checklist menu by moving the cursor to the drop-down menu of top left of the MFD and clicking on the checklist menu. The checklist menu allows you to access any of the checklists with ease and identify which ones are complete. Right now, I'll quickly go through how exactly checklists work here. Of course, first you need to select a checklist to open. Let's start with the cockpit preparation checklist, as it's the first one to be completed. Take a look at the color of the checklist title here. You see how it's blue? This will be important later, so just keep this in mind. Now, clicking on the title will take you to the checklist itself, displaying all individual items that need to be completed. So, there are two kinds of checklist items, sensed and not sensed items. As the name suggests, sensed items are automatically marked completed by the ECAM system, but the flight crew has to manually check the others. The vast majority of items are not sensed, but there are a select few sensed items. The sensed items can easily be identified since they don't have a checkbox to the checkbox next to it. The rest do have checkboxes next to it, indicating it is a not sensed item. So the first checklist item is gear pins and covers. It's in blue and it has an empty checkbox next to it. This means it's a not sensed item, and once we make sure that the gear pins and covers are removed, you can click on this to mark it as complete. Now you can see the color has changed to green and the checkbox is no longer empty, so we can move on to the next item. Fuel quantity has already been checked, so we can click on it to mark it as checked, and the box will fill and the color will change. Now if we take a look at seat belts, you can see there isn't a checkbox next to it. As mentioned before, this means that it is a sensed item that will automatically be marked complete once the criteria is met. In this case, the criteria is to turn the seatbelt sign on, as it tells us on the far right. Since this is a sensed item, if you try to click on it, nothing will happen. But if I switch the seatbelt signs on, you will see this will automatically change. And as you can see, I have set the seatbelt signs and this has automatically changed. And for flap settings, once we've made sure everything is set accordingly, you can click on it to mark it as completed. Now, once you've completed all items in a checklist page, you can click on the checklist complete button over here. This will mark the entire checklist as completed, and it will also take us back to the last page that was displayed before the checklist. Now, as you can see, it has taken us back to the flight plan page, because that was the last page we had open. We can navigate back to the checklist menu, and we can see cockpit preparation is grey. Now, I will navigate to the cockpit preparation checklist again, this time to reset it. As once we open it, you can see everything is grey because we've marked it as complete, but we can press the reset button over here to set everything back to its default state, besides seatbelt signs, which will automatically change based on the seatbelt sign, if it's on or off. Flight planning and checklists are only a fraction of the features available in the MFD. This has already taken us many hours to achieve, but I'm really happy with all the progress we've made so far. This means that we are closer to a plane that is VATSIM able and can fly A to B, meaning we are closer to an A350 release. On the topic of VATSIM, we have also begun hardware implementation for the CPDLC support on launch. This plane is a long hauler, and it would be kind of silly to not have CPDLC support. We can access the ATC communication section of the MFD by clicking on the drop-down top left of the MFD, and then clicking on ATC communication. As you can see, it will take us to the request page where we can click on drop-downs to reveal different sets of options. By default, you will have a blank page and these buttons which you can use to open up different pages and send certain requests. For example, if I click on the clearance page, we'll get a panel that gives us different options for clearances. Here we can request departure clearance, oceanic clearance, and generic clearances. You'll see that we can request an oceanic clearance by clicking on oceanic, which will open up this box window over here for us to fill. So now we can enter in the details accordingly. An entry point, which would be a waypoint. Your estimated time at the entry point in Zulu. Your mark level. And your current flight level. And once we fill in all the details, we can send it to the mailbox by clicking on this button at the bottom right of the page. This is one of the systems we are currently working on right now, and it is still heavily a work in progress. So even if I were to click this button right now, it wouldn't actually send anything. Moving on to the other pages we've completed, we have the surveillance pages. We can access the surveillance page by going to the MFD and clicking on the drop-down at the top left of the screen, and then navigating to Serve for Surveillance. You will land in the controls page where you can control the weather radar, terrain avoidance warning system or TAWS, and transponder and traffic collision avoidance system or TCAS. You'll see there's an indication here that the weather radar is inoperative. That's just an SDK limitation, and hopefully MSFS 2024 will have a solution. You can toggle different systems on or off by simply clicking on these buttons. For example, I can turn the flap mode off by clicking on it. This would only happen in case of a landing with abnormal flaps configuration, but I'm just doing it for the sake of demonstration. Anyway, now you can see the status switch to off, but of course you can toggle it back on by clicking it again. Some of these will actually ask you for additional confirmation before they're disabled because they're linked to other subsystems. For example, if I set the transponder system to standby, it will ask me to confirm this action. And once I've confirmed it by clicking on the confirm button over here, you'll see the transponder is now in standby, and the two other subsystems linked to it, which are the altitude data transmission and ADSB, are now also off. As a consequence of this, TCAS has also been put in standby mode, which can be seen on the bottom left as it is grey. An easy way to reset all these options back to normal is to click on the default settings button over here on the bottom right. This will set every system back to its default settings and enable it again, resetting any changes you may have made. Another useful feature we've added is the airport database page, where you can look up runway information for almost any airport. You can access it by first navigating to the FMS page, then clicking on data, and then you can navigate to the airport page. First enter an airport's 4-letter ICAO code, and then it will give you some basic information about the airport and its runways. For example, if I enter OMDB, which is Dubai International Airport, I will get the airport name, coordinates, and buttons for its different runways. As you can see, we can click on a button to give us more specific information about that runway, and we can scroll through all runways for Dubai International.
Hello, my name is Alex, and I'm excited to share the progress we've made on texturing the A350's cockpit. So far, we've completed texturing for several key elements, including the seats, side stick, tiller, throttle, and various miscellaneous items like the flashlight and the fire extinguisher. One of our primary goals throughout this process has been to deliver high-quality textures by also prioritizing resource optimization. This means that while we've aimed for intricate details, we've also optimized texture sheets to ensure efficient performance. It's essential to note that all the details we've integrated reflect those found in a typical A350 cockpit. Our approach strikes a balance, avoiding an overly weathered appearance while ensuring the cockpit doesn't appear overly pristine. We're particularly pleased with the attention to detail we've incorporated into the side stick. We've included details like fingerprints and stains, which are major contributors to the overall immersive experience. The same love has been shown to the throttle levers. While the base is very clean, in the real cockpit, the levers of course have those fine details because of their everyday use. Now, what took the most amount of time is the cockpit seats, and I think they turn out quite well. You'll notice a star pattern unique to the A350 seats on the base, backrest and headrests, as well as a detailed replication of the stitching on the edges. We've put similar attention to detail into small parts, such as seatbelts.
There has also been major progress made on the side consoles. We have managed to recreate this nice leather top finish that includes cup holders and other useful compartments.
Moreover, if you look closely, near the floor you'll be able to notice some dirt. During texturing, we've paid close attention to images from real aircraft, and we've managed to recreate dirt in a realistic way. Though there is not much of it, I can assure you that it is there.
That's it for now, but there's a lot more work going on behind the scenes that we hope to show you fairly soon.
Hello everybody. On the modelling side, we've been focusing on some miscellaneous parts of the aircraft, namely the cargo bay. The cargo bay is generally one of the most overlooked aspects of an add-on aircraft when it comes to the 3D model. As you'll see from these previews though, our attention to detail is second to none. Running along the roof, you can see the smoke detector and the fire extinguisher, which were modelled accurately using close-up photos. The individual metal tracks that run along the floor have also been modelled using more close-up references to capture each intricate detail, including the latches responsible for holding the cargo securely and the wheels that move the pallets around. The decompression panels, also known as the blowout panels, have also been modelled. This is still a work in progress as the cargo door still has to be completed, as well as the door mechanism and control panel, but I'm happy with how it's turned out so far. Now, let's take a brief look at one of the aircraft systems.
So, in addition to all the stuff you just saw, we've also been working on some of the core aircraft systems. Most of those are still work in progress, so we won't show them all today, but I will demonstrate some basic functionality of the fuel system. Currently, the system is in a normal configuration, with all of the fuel pumps set to auto. This includes the main and standby pumps from each wing and both of the center tank pumps. Because there is fuel available in the center tanks, the center pumps have automatically been set to run, and since the center pumps are running, the standby pumps from both wings are not active. Let's say a fault were to occur relating to the main pump in the left wing. I'll simulate this by simply setting its push button to the off position. Now, because the main pump is not detected to be providing enough fuel pressure, the standby pump has automatically taken over. Then, if I re-enable the main pump, the standby pump will become inactive again. Another instance where the standby pumps run is when the engines are only using fuel from the wings. For example, whenever there is no more fuel available from the center tank. I'll quickly show you how that works by setting the center tank fuel to 0. Now, let's say there's a fuel imbalance between the wings. To fix this, we can enable the right wing to center transfer, which will start a gravity transfer to the center tank from the right wing. Just note that the speed of the transfer is exaggerated for the sake of this demonstration. So after some time, the wing tanks have been balanced. That's it for the systems side right now, but we are actively working on multiple other systems which we hope to show in the next video. If you are skilled in Rust and are willing to put some of your time into developing the systems of the A350, you can apply at the link in the description. New developers are always welcome. Okay, one last thing. I just wanted to share a screenshot of our in-progress Navigraph implementation in the OIS, or Onboard Information System. What is being shown on screen right now is the en route map, which essentially helps you increase your situational awareness of the surrounding geography and airports, waypoints, airways, etc. We will also include the Navigraph airport charts, so hopefully we'll be able to show that next time. So that's it for this update. If you're interested in working with us to develop this aircraft, you can fill out the application form, which will be linked below. And if you are a pilot, engineer, mechanic, or work with A350s in any other way, please reach out to us through Discord or email. Thank you all for watching, and we'll see you again soon.